factoring was so much fun that we're going to spend another day on it. And this time we have a really nice method and it's called grouping or chunking. Okay, and we are going to use grouping or chunking when there are 4 terms. So yesterday we focused on trinomials when there are 3 terms. Today we're going to use grouping and chunking when there's 4 terms. So if you take a look at your first example, you've got x to the third plus 2x squared minus 9x minus 18. Okay, and the grouping or chunking method says, okay, let's draw an imaginary line right down the middle and treat these as 2 separate pieces. So now when I look at my first chunk, I want to say, what can I take out of x to the third and 2x squared? So take out the greatest common factor. So the greatest common factor between x to the third and 2x squared is an x squared. So now this is kind of going back to the very first part. You're going to say, okay, x squared times what gives me x to the third? X. And then x squared times what gets me to 2x squared? And that's a 2. So you're doing that kind of greatest common factor method first. And then you're going to go ahead and you're going to do that on the second side as well. So now we're going to say, what can I take out of negative 9x and negative 18? Well, I can take out a negative 9. So if I take out a negative 9 and I say, what do I have to multiply to get a negative 9x? I've got an x. Take a negative 9 out of negative 18, and I'm going to get a plus 2 because negative 9 times positive 2 is the negative 18 that I'm looking for. Okay, so now that I've done that, that's the hardest part. If you do it correctly, okay, these two will be the exact same. If they are the exact same, that's fantastic. What you get to do is take the coefficients and bring them down together as their own factor. So we can have x squared minus 9 as one factor, and then we can drop down the x plus 2 as the factor right next to it because that's what they had in common. Okay, so you take the coefficients, bring them down together into one factor, and then just drop down one x plus 2. Now the only thing here is we know that x squared minus 9 is the difference of squares, so we can break that down one more time. So we've got x and x. To get to 9, we've got 3's, and then we need 0 x's in the middle, so I'll have 1 plus and 1 minus, and then I'll just keep my x plus 2 at the end. Okay, so get used to the difference of squares, okay, and then break it down, square root both, 1 plus, 1 minus all the time. So that's how we're going to factor example A. You might like it better because there's less guess and check, okay? It is what it is, okay? So again, we've got 4 terms. We're going to split it right down the middle. I want to know the greatest common factor between 6 and 2. That would be 2. The greatest common factor in my A's would be 1A, and then no B's or C's. So now if I take a 2a out of 6a squared b, I need to multiply that by 3. I need one more a, and I need a b. Okay, so 2 times 3 is 6, a times a is a squared, a times b is b. Again, if you're not sure and this isn't going very smoothly for you, okay, just make sure that you check by distributing through to see if it works. So 2 times 1 is 2, I've got my a's, so all I need for that second piece is a c. Now I'll go ahead and I'll look at my second piece over here. What I have in common between 3a squared b and bc is just 1b. So I've got b, I need a 3ab for the first piece, and then I just need a c in the second piece. Okay, again, life is good because our middle pieces are the same. Since they are the same, I can take my 2a and my b, bring them down together. That's a 2a plus b, okay? And then I drop down one of these to be 3ab plus c. Now 2ab and those don't break down anymore, so that's just our final answer, okay? Maybe I should have written a plus b up here originally so that you saw that was 2a plus b. Whatever the symbol is there, it'll either be a plus or a minus when you put it together as your factor. All right, let's try c, same idea, okay? Break it right down the middle. What can you take out of the first side? Out of the left side, you can take a y. That's going to leave me with a y minus x, because y times y is y squared, y times x is xy. Okay. Out of the right side, I can take out a 5. So I'll take out a 5. That'll leave me with x minus y. Well, that's weird, because y minus x, my two pieces, are not the same. Okay. However, if I change my plus 5 here to a minus 5, couldn't I switch the y minus x as well? And now we'll just see. So test me. Is negative 5y what I started with up here? Yep. Negative 5 times negative x. Is that positive 5x that I started with? Absolutely. Okay, so by reordering it sometimes, you can help yourself And then now in the middle, I still do have y minus x, so I can put them together. Okay, so if they're the same, they're similar, but the signs are wrong, change the sign on the outside one, and then you can bring them together like you have on all of them. So I'll put together y minus 5 as 1, and then my y minus x I just write once. And those factors don't break down again, so you're good to go. All right, hopefully we're liking this better. We've got one more to try, so we'll take a look at D. Again, you split it right down the middle. You say, what can I take out of the first chunk? So the common factor there would be an x squared. If I take an x squared out of an x to the third, I have 1x left. If I take an x squared out of 3x squared, I just have a 3 left. Okay. Then I'm going to look at the second side, and I've got a negative 16x and a negative 48. So the greatest that comes out of there is a negative 16. Okay, leave me with an x and a plus, careful with your sign here, a plus 3. Okay, so again, check yourself. Is negative 16 times x, negative 16x? Yep. Negative 16 times 3, negative 48. Okay, and life is good. Okay, our factors are the same, so I can bring the coefficients down together as 1. So I've got x squared minus 16 as 1, and then the x plus 3 drops down as a separate factor, but you only write that once. And hopefully you didn't square it yet. Okay, this squared, okay, means you have to break it down again. Okay, so break down again. Okay, so if you have the difference of squares, you got to break it down. Okay, so this is going to break down to x and x. Again, remember, if it's a perfect square, square root it. So 4 and 4, and I need the middles to cancel, so it's going to be 1 and plus and 1 minus. You really want to get used to doing the perfect of squares, square root both, 1 plus, 1 minus. Okay, this is a huge topic, okay, and that is really going to help you if you can remember it. And then just drop your x plus 3 down, and that should be your answer. So hopefully today's a little nicer, less guess and check, but please write down any questions you have, and we'll go over those tomorrow.